So a number of hours ago, and I don't clearly remember how many hours because I'm so incredibly tired as I'm recording this, but anyway, the Running Out of Toes mission took off from New Zealand for Rocket Lab, carrying two very important satellites from an absolutely vital customer, Black Sky. And for those of you who watched my live stream, you got to see my first amateurish effort at trying to live stream something like this remotely with the help of people across the Atlantic, and due to my own issues it didn't exactly come off perfectly, but we've got some plans to make it better for the future. However, my own problems cannot begin to compare with what happened with Rocket Lab, and I stand by my initial statement that it was tragic, because at this point Rocket Lab has less than a 90% success rate since their first failure of their first test launch. They've had 20 launches and 3 failures if you include that first test launch. If you don't, then still 2 failures and less than a 90% success rate. Now, I'm not saying there's anything wrong with Rocket Lab or that they can't be successful in the future. I strongly believe in these people. However, they are going to be facing some serious competition from other companies that may be able to claim a higher level of reliability. And the Black Sky satellites that were launched could not have been a more high-profile customer. But in light of this, we must remember that everybody has had their share of failures, some of which have been extremely high profile and have involved the possible loss of life of people on the ground because of the space agency's policies. Nothing could be more obvious as far as this is concerned than the policies of Roscosmos, who do not believe in flight termination systems, as can be seen from this video coming up. And I have an inside line on the conversation that was taking place by the commentators. So check it out. And liftoff of the Proton rocket, one of the most reliable rockets in Russian history. Isn't this a wonderful sight, Joe? Sergey, is it supposed to be doing that? Don't worry, this is Russian technology, nothing to worry about. Sergey, you should hit the flight termination system now! We do not believe in flight termination charges, it is failure. Oh my God! What are you worrying about, you wussy American? This is Kazakhstan. They are used to running away. We used to drop nuclear weapons here. Or you might want to look out for the shockwave. Shockwave? What shockwave? Hello, and welcome to another episode of the Angry Astronaut. So, from this intro, and once again, I hope you guys appreciate my humor. Those of you who have been following my channel for a very long time probably remember a modified version of that skit from the past. But anyway, I hope you enjoyed it. But it does beg the question, with everything that's happening right now, with the Rocket Lab failure and everything that means to them, and the Falcon 9 sending up another bunch of Starlink satellites. I mean, it's just, I don't know how many there are up there at this point, but, SpaceX is clearly on a mission to complete that constellation as rapidly as possible. And also with Starship having put out a plan to launch in next month, an orbital, or some would argue suborbital, because it does not complete an entire orbit before it splashes down, but getting Starship into orbit when the Super Heavy has not even been tested yet, or even stacked or built. All of these things are very exciting, very controversial. Why would I not be talking about these things instead of the Trojan asteroids? Well, it's because I'm angry about the subject. I knew almost nothing about this. Almost nothing is being discussed about this matter. It's not in any of the space news periodicals. It's not online. You really have to do a little bit of digging to even find out anything about Lucy. And it's launching in October. 5 months away. And, if there's virtually no press about it, one would argue that it's a completely unimportant mission. Well, from a scientific standpoint, it's incredibly important because it's going to teach us a great deal about the earliest origins of the solar system. These asteroids, or planetesimals as some of them are as old as the solar system itself, having, sustained very few changes over the last several billion years. So it's going to teach us so many things about the solar system that we simply do not have here on Earth. Even on the moon has suffered so many meteorite impacts over the last several billion years that there are many places on the moon that are much more recent than the Trojan asteroids. But a lot of people, even people who are involved in spaceflight and space science, really don't give a damn when it comes to science for science sake. And I can see that. Practicality means everything. As you're going to see in the video, the amount of money that we spend on virtually everything besides science indicates that the human species has very little emphasis on science for science sake, as opposed to practical things, like, defending the nation against real or imagined enemies. So, and there are many other things besides that, but still, so little is spent on science for science sake. So why would this Trojan asteroid thing really be that interesting? I mean, yeah, it's cool stuff and all that, but it's just a bunch of asteroids, who cares? Well, I'm here to tell you that it's a very important mission from a practical standpoint as well as scientific. I've done a lot of digging about this, and in actuality, and once again, just like the Lunar Gateway video, this is not clickbait. This setting up a base in the Trojan asteroid field, or rather there's two of these fields under the influence of Jupiter's gravity, would be instrumental in protecting the Earth from hazards from the outside, from asteroids and comets that might impact us in the future. And bases located in these asteroids, amongst these asteroids, would be the most effective places to put defense networks against these sorts of dangers for the future. The best. And I am going to explain exactly why that's the case and other uses for the Trojan asteroids right now. Now, a lot of you have seen this graph before, but I think that it strongly demonstrates just how little people give a damn about science for science sake versus other things like the military. The red bars are various military spendings, both direct and indirect, and the green on the left is all the sciences, not just NASA, but everything. So obviously finding a practical solution or a practical use for a space mission is always good. Now, in October, to be precise, October 16th of this year, an Atlas V rocket will carry the Lucy probe all the way to a very special destination that has never been explored by the human race in history. Now, SpaceX fans may be wondering, why the hell does NASA keep using this expendable rocket for all of these high-profile scientific missions? Well, there's one very important reason. Even though they're using a Falcon Heavy for the Psyche mission, which is a very important asteroid mission, the Atlas has a completely spotless record. That's right, not one mission from this rocket, from its very inception, has ever failed. And It's over 100 launches. This is one of the few rockets that's regarded as being completely safe to carry nuclear materials into space. This is a solid rocket and worth the expense, even though it's going to be replaced by the Vulcan Centaur, which will be far less expensive for a variety of reasons and ultimately have a lot of reusable aspects. But still, the Atlas is a great solution for important scientific missions that you don't want to lose. ULA will be carrying a very important payload, the Lucy Spacecraft, which will be engaged in a 12-year mission to explore 2 swarms of asteroids that follow in front and behind of Jupiter, and they are trapped in what are called Lagrange points in between Jupiter and the Sun. Gravitational parking lots, essentially, and we have them associated with our planet as well. Once these asteroids are trapped in these locations in front and behind of Jupiter at a 60-degree angle, they never leave. So we're talking about asteroids that got trapped in these locations billions of years ago and never went anywhere. And if you're wondering about numbers, there's estimated to be over 1 million of them, a kilometer or more in size. Now, the first of Lucy's targets will not be a Trojan asteroid at all, but rather an asteroid in the asteroid belt called Donald Johanson, named after the discoverer of the Lucy skeleton, which was probably the most important discovery as far as human evolution is concerned. Now, after making 2 gravitational flybys of the Earth to increase speed, Lucy will sweep through the L4 group of asteroids ahead of Jupiter, exploring 4 very large asteroids, some of which are hundreds of kilometers in diameter, and yet we know virtually nothing about them. It will measure composition, temperature, all sorts of data, and then make its way to the L5 group of asteroids, which trail Jupiter, and there it will study one target in particular, 2 asteroids that orbit each other at a distance of only 600 kilometers. Can you imagine what the night sky would look like from the surface of one of those asteroids? The companion asteroid would be many times the size of the full moon and would regularly blot out the sun. But in any event, the whole objective is to study the history of the solar system. As you can see here, this is extremely important because as of right now, our understanding of the formation of the solar system is a bit spotty. What really makes these asteroids different from all of the planets in the solar system? Well, one of the most important things is nearly all of these planets have been substantially changed by their development over time and just by their very nature. Volcanoes, tectonic activity, even the moon has been impacted by these sorts of things, whereas these asteroids have been barely touched. So they can tell us about what the solar system was like at the very beginning when everything was forming out of a massive cloud of dust orbiting the newly formed sun. And right now, we can barely see these asteroids, even with the Hubble. They only appear as tiny dots of light, which is why this mission is so vital from a scientific standpoint. But okay, as far as the vast majority of the population of this planet is concerned, who gives a damn about the ancient history of the solar system? What difference does it make? And it's difficult to answer that question. It doesn't really impact our day-to-day lives, nor is it going to have a major impact on our civilization to go and study these asteroids. Or will it? Will this probe, then you can see the solar array being unfolded here for the first time, just about ready to go, this thing. I'm so excited. But how will this thing actually impact our civilization and make a difference to us on a day-to-day basis? Well, you know something? In the future, establishing a base on an asteroid like this one, which by the way is not being studied by the probe, could not only provide our civilization with an almost limitless amount of resources, but could also defend us for hundreds or even thousands of years into the future from almost certain annihilation. And yes, if you think I'm overstating things again, well, it's just like the video that I did about the Lunar Gateway, except this is taking it to the next level. Establishing a base in the Trojan Asteroids would be the ultimate defense against asteroid impacts in the future, or even incoming comets from the outer solar system, or perhaps even interstellar sources. And yes, sooner or later, something like that is going to represent a massive threat to our planet, and the best way of stopping it is in the Trojan Asteroids. Let me explain. Now, asteroids that threaten our planet do not orbit like normal planets do. They orbit at extreme angles and in a highly irregular fashion. As you can see, they come pretty damn close. But let's have a look at the orbital pattern. As you can see, when the asteroid gets to the furthest extent of its orbit, it slows down when it's the furthest away from the sun. Look how slow it's going at that point. And then as it approaches the sun, and therefore our own planet, it speeds up considerably. So the best place to intercept an asteroid is when it's at the furthest extent of its orbit, also called its apogee. An asteroid interception mission launched from Earth or even lunar orbit is not only going to have to escape a lot more gravity, it's also going to have to contend with slowly increasing speed from the incoming asteroid. The closer the asteroid gets to Earth and the Sun, the faster it goes and the more impossible it gets to divert it from its course. The ideal situation is to identify the asteroid when it's going back into its position of apogee and then hit it with a kinetic penetrator or some other type of anti-asteroid weapon and knock it off its course. Even a slight diversion this far out in its orbit will change it sufficiently to miss the Earth entirely, and this is so much easier to do if you do it from the Trojan Asteroids. You wouldn't have to even build a base on an asteroid. It might be better if you didn't. Instead, you would build a rotating base complete with artificial gravity in the asteroid belt, utilizing in situ materials mostly. And yes, this is far in the future, but still something that should be a goal, an objective. But once we did it, it would be a lot easier to construct it, because the materials, as you put it together, wouldn't go anywhere. Remember when I said that this was a gravitational parking lot? The reason these asteroids have stayed put for billions of years is because of gravity. A perfect balance between Jupiter and the sun. A perfect dance in the solar system by 1 million participants. Unbelievable and really kind of magical. And let me tell you something, if I were to build a base close to an asteroid or utilizing an asteroid, this would be my target, Patroclus. And the reason this would be my target, and by the way, this is the last destination of the Lucy probe, is because it is a binary asteroid, as you can see, and as I briefly spoke about before. 2 asteroids nearly the same size, orbiting each other at a distance of a mere 600 kilometers, and both of them are over 100 kilometers in diameter. They would be gigantic in each other's night sky, and you could tether the 2 of them together with a space elevator and put your base between them, spinning like a top essentially between the 2 asteroids, generating artificial gravity. You could then send rail cars down the elevator to both asteroids, utilizing the resources on both of them. We suspect that there's a great amount of water ice and other vital materials on both asteroids. So the mission of this base would be twofold. Number 1, to mine the resources of the Trojan asteroids, and number 2, to defend the Earth against incoming asteroids and comets. Let's talk about the first one. Given the huge variety of asteroids that there are in these swarms, once again, a total of 1 million of them that are at least 1 kilometer in diameter or more, there's likely all kinds of rare metallic elements in these asteroid swarms that would be incredibly valuable to our civilization. On top of that, there's enormous amounts of water ice and carbon that could be used to manufacture, of course, oxygen, water, and methyl ox fuel, assuming we were still using that in the future. All sorts of such valuable resources to our civilization, utterly vital to our long-term survival. But of course, this would have a secondary goal, in my opinion, to deflecting incoming asteroids headed for Earth or perhaps towards our other colonies. So in terms of asteroid deflection, the base would serve two purposes. First of all, as an observatory, and yes, this is a space elevator from Earth, which by the way is practically impossible with technology today or even in the far future, but still it illustrates the whole rotating artificial gravity base concept on a space elevator. Anyway, an observatory located in the Trojan asteroids would have a much easier time identifying incoming asteroids, especially something coming in from the outer solar system. No interference from space junk, no interference from the atmosphere, no interference of any kind, and it would have a better view of things coming in from the outer solar system. And in case you think Jupiter provides some sort of defense against it, as has been suggested a number of times, there are an equal number of scientists who believe that Jupiter actually presents a greater threat. Its enormous gravity pulling things in from the outer solar system and slingshotting it into the inner solar system on a collision course with our planet. Jupiter may be as much of a curse as it is a blessing. And then, of course, Patroclus could also serve as a sort of missile base, with kinetic penetrators or some other method of deflecting asteroids, using almost no fuel or perhaps zero fuel to escape from the asteroid, since they have such a tiny amount of gravity, and you could actually use the rotation between the two asteroids to fling a missile off of the system and head it towards an incoming asteroid. It would be so much easier to intercept and deflect from that distance. Plus, those who are stationed on an asteroid such as this would have a hell of a night sky to see, and some of these asteroids are actually companions with comets. That's right, we've spotted cometary tails in the Trojan asteroids along with the asteroids themselves. The night sky would be filled with all sorts of points of light aside from the stars that we're used to here on Earth. Not that you would want to stay there permanently, of course. Now, if you think this is some kind of nutball idea out of my own deranged mind, it isn't. This is something that a group of scientists came up with, this whole concept of a base used for resources and deflecting asteroids, and it's linked in the description. So it really is a valid plan, and it's something that we can't do until we study the asteroids themselves. And Lucy will be the first probe to do that in detail. It's going to be an amazing mission. And so, just a few months from now, this very reliable rocket, which is expendable and is wasteful, yes, and should be replaced at some point soon, but still, I'm gonna feel good about this rocket carrying such an important mission to a place where human beings have never looked up close, one of the few places in the solar system that still has not been explored at all. And it's going to be a moment to remember. And not only that, it's not just going to be for science, and that's a reason enough in my opinion. It's going to be for the future of our species. So, as usual, I want to make one thing perfectly clear. I do believe that science, for science's sake, is indeed important. That it's something that we should pursue, regardless of whether there is a practical application for anything that we study, especially when we're talking about space. But nevertheless, without practical applications, the governments and private enterprise that would support such missions simply aren't going to go. You're going to be talking about consortiums of scientific organizations, universities, that sort of thing, who don't always have the many millions or sometimes billions of dollars necessary to support these kinds of missions. And so therefore, you need the support of people who need some kind of practical carrot, something that looks appealing to them, something that is going to benefit our civilization. And tragically, because the moon, as we discovered, had nothing to do with science, the Apollo missions, but rather simply beating the Soviets, and once that was accomplished, we simply stopped, and so did they. This resulted in huge practical consequences for the planet. There are so many things, as we have learned now, that are on the moon that would be so useful to our civilization, from huge orbital solar arrays that could provide almost limitless power, to fusion in helium-3, to all sorts of resources that we could be exploiting right now, that we could have been exploiting for decades if we had simply stayed the course. But we didn't. We instead decided that there were more important things to spend our money on, like the Vietnam War. There continues to be huge numbers of people who keep saying, oh, we need to not worry about space and focus about things right here on Earth. We do stuff like that. If we continue to focus right here on Earth, we are going to destroy Earth. Our civilization simply consumes too much in the way of natural resources, power, etc., for this planet to sustain us as our population grows. Even with our current population, we cannot sustain our civilization on this planet alone. It cannot be done. But in any event, I am always on the lookout for practical applications for any mission, and I think that practical applications definitely exist here if we're just a little bit innovative and think outside the box. If you like the way I do things, if you like the things that I have to say, it's all in the description and how to support me. And by the way, I got a new thing. The Saturn V. Yes, indeed. I'm going to be doing bit by bit a Saturn V build for you guys, and it's going to end up on my set somewhere, although I've yet to figure out exactly how I'm going to do that, but I'll figure it out eventually. And thank you very much to my supporters. And as I say, times are tough. A like and a subscribe, and I would be a very happy person. So until the Lucy mission is making its way to the Trojan Asteroids on this extremely long mission and reveals so many new secrets and so many breakthroughs to the human race, and until we have the wisdom and the innovation to exploit and take advantage of these new discoveries that are certainly there amongst these huge clouds of asteroids that are under Jupiter's influence and follow it around like a bunch of little children and have been for billions of years, until we learn how to harness all of the resources and all of the advantages that exist here and elsewhere in the solar system. I urge all of you to stay angry about space.